Hello, Internet. I'm going to be making a few videos where we code fun things together to show that coding can be very fun when you're building things you enjoy, and you learn a lot along the way. I'll mostly be using vanilla JavaScript and HTML, so we don't have to learn any complicated tools or frameworks. I might look into Svelte later because it's so simple. Today we'll be copying this real-world art by Hediye Shafieh. In the real world, these are rolls of paper where the edges are painted and the rolls are stuffed into this big circular frame. So on the right is the original art, and then on the left is the version that we're going to be making. I think it looks pretty similar. Let's get started. I'm going to make a single HTML5 index.html to keep everything simple. And we're going to use Canvas for this. So let's make our canvas. Let's make the width, I don't know, 1200 pixels, and the height, 1200 pixels. And so now we've got nothing, but if we open up our page, we can see our canvas. So let's start writing JavaScript. Let's get our canvas. Const canvas equals document.getElement by ID canvas. And we set the ID here. And so if we try to log our canvas element variable, and we go to the console, here it is. So we have our canvas. Let's draw a circle on it. HTML canvas, draw circle. Arc method, perfect. Just pull all of this out. I do want to use a const though instead of a var. And then this is because our canvas is named, has a different name here. All right, we have a circle. Now let's just draw a million more. Since we're going to be drawing so many circles, I want to make a function to draw circles. So go ahead. And I know it's going to take the position of the center and the radius, but I might want to add colors and other parameters, line thicknesses, and things like that. So I'm going to make the parameter an object, and I'm going to destructure it immediately now. But this lets us add more parameters and make all of them optional as we go on. So let's take all of this, and we're going to put it in. And so if I recall that doc page, these are the parameters, x, y, the radius, the starting angle, and the finishing angle, which in our case is 0 and 2 pi. So here, well, now we're not calling our function anymore. Let's start drawing the big circle. Since we're going to be reusing these variables over and over, this magic 1200 number over and over, I want to save it in a variable. So we want width equals 1200, height equals 1200, big center x equals width over 2. I'm going to assume everything's a square. And then big radius is also going to be width over 2. But now we can draw x equals big center x, y is big center y, and radius is big radius. So now we should get a circle that covers the whole page. All right, nice. But if you remember on here, I want to draw, I want this to like draw a frame. So I want to paint it gray and I want to make it thick. For that, I'm going to put in some extra parameters. I'll put in one is going to be called line width. And if line width is set, then we can do context dot it's stroke width equals line width. Let's try that. Big radius, line width equals 10. Oh, it's not that. Let's go look it up. Canvas set stroke width. It's line width. Wouldn't you know it? All right, now we have a thicker one. And then also I'm going to want a border color. So we're going to do the same thing here. If somebody gives us a border color, we'll do stroke style. border color. And then here, border color, make it light gray. Great. That's pretty similar to here. That's good enough for me. Okay, so we have our circle, and actually, on this picture, the parts that aren't filled in, uh, they're in black. So I want to fill the circle in black to give it a background. So I'm going to give it a fill color, which is going to be black. So if fill, I got to add it as a parameter. If fill, we're going to want dot fill style. And here we actually need to tell Canvas, instead of just drawing, it needs to do, we have to do a separate command to fill in the path. We have to call fill. All right, we have our black circle. Let's make a for loop and try to draw maybe 1,000 circles. So our trusty for loop plus, and then we're gonna pick a random starting point, which is gonna be random times width, and same for y. And if it wasn't square, this wouldn't matter, but they're the same number. But it's nice to try to keep your variable straight. And then let's just say draw circle, x, y. Let's give the radius, just set it to 20 for now. And let's see what we got. All right, 1,000 other little circles. I want to fill them in with the color, so let's just fill them in with green. All right, and I want to have them to have a line width of 1 because that's a little bit ugly. Now we only want to draw circles that are inside our frame. And this is a really common problem, choosing random points inside a circle. And it turns out that one of the best approaches is just drawing all the points and then rejecting all the ones that are outside of our initial circle. It's called rejection sampling. It sounds like it's not as fast because you're on every attempt, you don't always get a circle. You might be very unlucky in picking lots and lots of points outside, but it turns out that it works very well. And the other approaches are more complicated. So what we need to do is when we have our x and our y, we need to see if they're within the distance from this x and this y to our big center x and big center y is less than our big radius. And if it's not, then we need to, we're going to just continue. We're going to skip our for loop. And we'll put the draw command at the bottom here. To tell if the distance between the point for our given circle and our big center, we're going to use a distance equation. The distance equation looks like this. And so that's what we'll do. We'll do our x minus big center x and our y minus big center y. And we'll check if it's bigger or smaller than our big radius. And there's a trick that's commonly used, which is that if we're only trying to compare the right-hand side and the left-hand side, we don't actually need to take the square roots because square roots are very expensive for computers to calculate. We can actually keep the right-hand side squared, and we can ask, is d squared greater than the sum of these two squares? And that's actually faster for the computer to do one more multiplication than to do an expensive square root. So let's get at it. So we want x minus big center x, and we need to square that. Python has a nice little squaring operator, but JavaScript doesn't, so we'll just multiply it again. Y minus big center y itself, y minus big center y. We can put these, not getting much room here. We can put these on a new line to make it a little clearer. Maybe we could be consistent. Wow. Okay. And we need to check if this sum is greater than big radius times big radius. And if so, then we're going to just skip this drawing call. All right. So now we're not drawing any circles whose center is outside of our frame. We have two issues here. One is that we didn't account for the thickness of the border. And the other one is that a circle might have a center that's really close to the edge and it might overlap. I'll come back to this later. I don't want to deal with it now. So we have all these circles now, but I only want to draw non-overlapping circles. So what I'm going to do is I'm going to keep track of every single circle that we draw. And when I come up with the new circle, I'm going to check if it overlaps any of our previously drawn circles. And if it overlaps any existing circles, then I'm going to skip that one as well. So let's make a variable to store our circles. And when we draw our circle, we're going to push our x, y, r to it. And then here, when we're doing our checks, we're going to ask if collides with other circles, and we're going to give it our proposed x, y, r. We could just make these like this. And then if it does, then we're going to also continue. So now we have to go make this function. So let's get started. Function collides with other circles, x, y, r. I need to go through every single circle that exists. So let's make this other circle of circles. And then I'm going to ask if, and then I'm going to make another function for the collision. Collides with, so here we'll ask x, y, r, and we'll do other circle dot x, other circle dot y. You know what, actually a neater way to do it is to turn this into a single object. We'll do circle, other circle, and we'll pass in the two objects like this, and that is slightly cleaner. If it does collide, then we just need to return true. Otherwise, if we've gone through every single other circle and we've checked the collisions and it doesn't collide with anything, then we're good to go. We can return false. Let's make another function to check if two circles collide. Circle 1, circle 2. Let's abbreviate these a little bit, because in this case, we're going to be pulling everything out of them. Or actually, the cleanest way to do this, you pick that. So we're going to return, so now to tell if two circles collide, for example, this one and this one, we're going to use the distance equation again, and we're going to say, this is the distance from the center of this circle to this circle, and we're going to ask, is that distance greater or smaller than the sum of the radiuses of the two circles? And if the radiuses are very small and they're far away, then it's good. But if the radiuses are very big, then they might collide. So we're going to apply our distance equation. So this is going to be c1.x minus c2.x times itself. Maybe I can just copy paste. Plus, and I can do the same thing here, but just replace everything with a y. So if this entire thing in our parentheses, if it's greater than the sum of the two radiuses, then we're good to go. So here, actually, we're going to want a small. And in this case, so a clean thing we can do is whenever you have like if something, and then you want to return true, and then if it's false, you return false. A quick little thing you can do that's kind of neat is you can just return the thing in the if statement, because if it's true, then you'll be returning true, and if it's false, you'll be returning false. So we can do the same thing here. How about two parentheses? Why don't you like computer giving me the syntax errors? Oh, it's because of this plus. Okay, so I think this might just go and try this. Let's see it. Nope, didn't work. Completely fine. Okay. C1.x minus. Oh, I know what we did here. We forgot to square our other side. Useful trick, do not take the square root, but you got to remember to square the other side. All right, there we go. All these beautiful non-overlapping circles. I really like these green circles. Let's do one little quick thing. Let's just make these different sizes. Let's just do 20 plus. Then some of them are bigger than the others. Great. So we have two important things left to do. One is to make it match the colors, then to fill in the circles like the rings. And then the other part is to completely fill the frame with circles. I'm going to start on the colors first. So I already went ahead and I wrote a little script that looked at the picture, which I already downloaded also. And I went and I took random points inside this picture. These are the random points. And I'll make sure to only take ones that are within the picture frame. And then I printed these pixels out, and I wrote this all to one big JSON file here, which has a bunch of sampled colors. So I'm just going to take this JSON file, and to be as simple as possible, I'm just going to dump it in the HTML. You could serve it as a different file, but then I think I don't really want to have to deal with the same origin policy or any kind of complications or anything. So let's just go here. What's going on? How do I use my tools? Here we go. And let's just paste it. Just save it in an array called colors. Okay. So we can start with now is that instead of making the color be green, here we can pick equals. So we're going to need math.random times colors.length. But math.random gives you a number between 0 and 1, and colors.length is an integer, and this will give us the index of a particular color that we can look up in the array. But we want to make sure we turn this into an integer so we can look up. We don't actually want color 2.65. So for this, we need to use the floor function. And we want to make sure that we use floor because we don't actually want to use, if there's 10 colors, since we index from 0, the last color is 9, and we don't ever want to like do math.random times 10 and come up with like 9.5 and then round up to 10. We always need to round down to 9. So here we'll have a color, and now we can fill it with a different color. Well, the fill did not pop up. This is because color is actually still just a random number. We actually need to look it up in our array colors. Okay, I know what's going on here. Problem is that we gave it our fill object is an object, our fill parameter is an object of RG and B, whereas we need to give it an HTML color. So for now, let's make an HTML color. And there's a really easy way to do this. In HTML, you can give RGB colors. So we're going to use these backticks, and we're going to do some string interpolation. We can do color.r, comma, color sign, color.g, $ color.b. And this will give us a nicer. There we go. Now we have this nice, these little pills. I think this already is its nice little piece of art. But let's go draw the inner rings. And actually, I'm going to pull that out into a function. We're going to draw circle with rings, so we'll call it. So we'll need an X and a Y and a radius, but then the rest we'll pull out of, we'll pull into the function. So we'll pick the color here, we'll pick the HTML color, and we'll actually do the draw circle call here. Instead, we'll do a draw circle with rings call, X, Y, R. So for now, this should be exactly the same. All right, good. It's always good to check your code along the way. I think to remove this little border, what I'll do is I'll just make the border color also our HTML color. All right. And now to draw the rings, we're going to draw our initial circle, and then we're going to draw another one with a smaller radius and another one with a smaller radius until we get too small. So let's keep track of our current radius. Current radius equals r, while current radius is greater than, for now, 1. And then here we'll draw a circle. We can move all of this into here. And then we can say current radius minus equals maybe 5. So we're drawing rings of size 5. Oh, not happening. This is because we're still drawing, we need to use current radius as a radius. All right, very nice. Now we're having little rings just like in our picture. Maybe we can make the rings a little bit smaller. I think that looks a little better. Okay, so now let's move on to filling the circle. So one thing we can do is we can just try a lot more times. And this gives us a much better filling, but what we need to do now is we need to actually fill in the extra spaces. Instead of rejecting a circle if it overlaps with an existing one, shrinking it so that it fits and doesn't overlap. So instead of just completely rejecting the circle, we're going to make this collides with other circles, return the amount that we need to shrink the circle by so that it'll fit. That means that collides itself isn't going to be returning us just a true or false, but it's actually going to return us the difference between the two. We're going to return this minus this. So now instead of an if statement, we're going to save the return value in a variable. And then now we can say if radius diff is greater than 0, we could return true. And I think this should still give us the same code. I just want to keep track. This is good still. So since a circle might collide with several other circles, we need to return the maximum amount of shrinking that we need to do. So we're going to keep track of all the radius diffs. And then if radius diff equals 0, radius diffs dot push radius diff. We're adding it into our list. Then now we need to check, did we put anything in the list? If not, we can return a minimum. We don't have to shrink at all. If the list has elements in it, we need to return the highest value in the list. And for that, we can call math.max with this ... radius diffs. The ... kind of explodes the elements in it. And so this is the same as if there were 7 elements in radius diff, this would be like calling max.math with 7 things. All right. I think my indentation is busted, but let's not worry about that. So now collides with other circles is going to return a radius diff. And instead of rejecting it if we have a radius diff greater than 0, only going to reject it if shrinking, we'd have to shrink the circle by way too much. For example, let's say if the circle gets too small, we don't want to have to draw it. So, and then we're going to make r equals r minus equals rd. So r is now mutable. We're changing it in a couple places. So we need to make it a let. Why does the computer not like my curly brace? That's because I didn't put one here. Okay. I think now we can pump it up. All right, now we're getting more and more matching circles. Let's just go hard. How come we're not still filling our space? Actually, this is slightly different than we need. Specifically, we need the difference between the sum of the radiuses and the square root. Oh, wow, it's drawing so many circles now. There we go. Oh, wow, it looks magnificent. Wow, compare the two. We're really getting there now. Looks beautiful. One quick thing I noticed is that the one on the right here is a little bit warmer than the one on the left. And I found a quick hack to make it a little bit warmer. And that's to use, here, I'll show you live first. And that's to saturate the canvas a little bit with a filter. You can use this saturate CSS, I think it's CSS3. And you tell it a certain amount to saturate by. So you can give it a huge amount. It can like really saturate. We can like more of a poppy field here. But if I want to just saturate by like 20%, I think this looks more like the original. I'm going to put that in here with style equals filter saturate 1.2. And there we go. That's saved now. Okay. What I want to do now is, I feel like there's too many small circles. I think the big circles are kind of taking up room, and then the small circles end up having to fill a lot of spaces. I'd rather have like a kind of more medium circle here than all of these lots of little circles. So what I want to do is I want to factor this for loop that we do into a function and then do different passes with different sizes of circles. So I'm going to make a function called circle pass. And it's going to take a number of tries, a radius choosing function, and just also take whether we should shrink on collision. I'm going to make the first pass not shrink on collide. Here's putting the for loop in a function. Then we're going to make this num tries. We're going to call this radius chooser. I'll save this for first call of function. And then shrink on collide will be another parameter. If we do not shrink on collide and RD is not equal to 0, then we'll just continue. So here, we're going to be putting this to 50,000 tries again. And I think this should look exactly the same. All I did was refactor the code. So I rewrote the code in a way that makes it easier for me in the future, but I didn't change any functionality. And that's really nice. So now what I can do is I can say, let's do a first pass with maybe some bigger circles. And then just try to fill as many big circles as we can. And then maybe a second pass with, well, it won't matter as much because they'll auto shrink, with smaller circles, with auto shrinking circles. Now we have these bigger ones. Actually, I want this to be false and this to be true. So the first pass has no auto shrinking and the second one does. And there we go. Now we have a lot of these really big ones. Maybe they're a little bit too big. Let's make this 25. Yeah, that's nice. And then maybe I'll make, I'll leave the filling in stage to later, and I'll make another, I'll try to fit in any like mediumer circles, say 20 actually, if I can. And at each step, let's print out how many circles we're making. So our first pass draws 161 big circles. Our second pass draws an additional 80-ish medium-sized circles. And then our last pass draws like 6,000 new, very small circles. And I kind of like where this is. I think you could tweak this a lot, but I'm going to leave it here. The one last thing I want to deal with is these circles that are too close to the border. So correct way to do this would be to reject the circle if its radius was, if it was outside the big circle plus its own radius. And this is what that looks like. But I really don't like the look of it. I like it going up till the edge of the circle. I don't know why it's not actually like filling in here, why it's rejecting circles that are of this size. And I'm not even sure, this might maybe also need to account for the border. So I don't like the look of this. So instead, I'm going to leave it as is. And I'm just going to do a really, really easy hack. And I'm going to just redraw kind of, I'll let it overlap. And I'm going to redraw the border on top of it and the white background. And it'll look a little different, but that's fine. It's my version. But to do that, I found this the Stack Overflow canvas draw inverted circle. And it has this like, basically this answer that I'll just take and dump at the end. And so our fill style is going to be white. And we're going to end up drawing our circle. So our circle is from the big center X, big center Y, and our radius is big radius. And then we're going to draw a rectangle. And apparently the order of these matters. I think there's a comment down there that explains that it's like this, I think. And let's see what this gives us. All right, the only thing we need to do is to also give it a stroke. Context, what is it? Strokes. We also need to give it a line width. Context dot line width equals 10. We got to do that before the stroke. Are we sure it's, yeah, that's stroke style. Great. So now we have light gray. This line is feel as thick as before. And weird. So there we have it. Hediye Shafier's circle rules made in Canvas and a few lines of JavaScript. Hope you enjoyed this video. I'll be making other ones, making all sorts of fun things, maybe either other generative art or little games. I think I might do Minesweeper next. And we'll see. Have fun coding.